In this tutorial, I'm going to explain why we use reverse operations or opposite operations to solve linear equations. And I'm going to start with talking about a balance here. So let's say that x was 3. So this is what that means if you ever hear a teacher or somebody talking about using a balance. It means that 3 is on both sides here. So this is, think of it like a teeter-totter. If you had like 2 people each with a mass of 3, or they put, you know, a little sack of potatoes that had a mass of 3 kilograms on one side and 3 kilograms on the other, as long as they're both on the ends the same distance from where it balances, then the balance is balanced. It doesn't like go down on one side. Now, if you do the same thing to both sides, it's still going to be balanced. So let's say I add 2 to both sides here. So I still have the 3, and I add a 2 to the left and a 2 to the right. See, I'd still have 5 here and 5 here. So for the equation, I would do the same. I do the same thing, and as long as I do the same thing to both sides, I add 2 to x, so it's x plus 2 on the left now, and I added 2 to the 3. So see, the equation would be x plus 2 equals 5 now, but it should still have the same solution. You can always check any equation by taking what you think is the answer and put it into the equation where the variable or variables are. And as long as it works out to be the same on both sides, then that has to be the answer. So you see, I think that x is 3. 3 plus 2 is 5. So that's how they know that 3 is the answer. Now, if instead, let's say I added a different amount to both sides. Let's say I still added 2 on the right, but I added 5. I added more on the left. So this now has 8 on the left, but only 5 on the right. That's why it's down on this side, because this side is heavier. So if you take our equation and add a different amount to both sides, what happens is you change the equation so it no longer has the same solution. See, 3 plus 2 add to 5. So see, if x was 3, this would have a value of 8 on the left, but only 5 on the right. So they're not equal. That's what that sign means. See, if 3 and 2 add to 5, so this equation would now be x plus 5 equals 5, and the only number that you can add to 5 and still get 5 is 0. So x would have to be 0 for this one, not 3 anymore. So that's why you have to do the same thing to both sides, because when you start doing different things to one side than the other, it changes the equation to no longer have the same solution. Unless by some fluke you did, like, say, different things in one step, and in the next step you did something to correct that, I think the chance of that happening is pretty slim. That's the only way you would keep the equation being the same. So we're going to take a look at on the next page. We'll get into these examples in a moment, but I'm going to show you how, like, I'm going to kind of build an equation here on the left. So I'm going to start with n equals 5. And what I'm going to do is I'm going to do the same thing to both sides. So I'm going to subtract 4 from both sides. So there's my subtracting 4. Don't worry that I noticed when I was running this that I was supposed to have read 4, but the color doesn't mean anything. Okay, so I'm still subtracting 4 from both sides. So 5 minus 4 is 1 on the right. N subtract 4 is still n minus 4. So this equation should still have the same solution. See, if I put 5 in here, 5 minus 4 is 1. So I know that I haven't changed it. It still has the same solution. So I subtracted 4 from both sides. Let's say I was to multiply both sides by 2 now. So I'm going to take the n minus 4 and multiply by 2, and the 1 and also multiply by 2. And again, notice doing the same thing to both sides. Now, on the left, this is called the distributive property. The 2 is said to distribute into the brackets, and everything in the brackets gets multiplied by that 2. So 2 times n is 2n. 2 subtracting 4 is subtracting 8, or 2 times negative 4 is negative 8. And on the right side, 2 times 1 is 2. So it's kind of like I've done these operations, same thing to both sides in both cases, and I've built a new equation that should still have the same solution. Okay, 5 should still be the solution, and I'll get into showing how to check that in a little bit. Now, let's say I didn't know that m was 5. So this is how I could use these opposite operations from this equation to get back to n equals 5. So the last thing I did was to multiply both sides by 2. So what I'm going to do next is I'm going to do the opposite. I'm going to divide both sides by 2. So I'm going to take this equation and divide both sides by 2. Now on the left, 2n divided by 2 is 1n. Now we don't normally write the 1 here, but that is the same as 1n. Subtracting 8 or minus 8 divided by 2 is minus 4. And 2 divided by 2 is 1. Notice this is actually the same equation as that one. So I did the opposite of this here. So let's do the opposite of subtracting 4 from both sides. The opposite of subtracting 4 is to add 4. So I'm going to add 4 to this both sides. So there's my plus 4 and my plus 4. Now subtracting 4 and adding 4 is really the same thing as doing nothing. So that is 0. So that's why I just have n on the left and 1 and 4 add to 5. So notice I get back to my solution that n should be 5. So that's what I mean by opposite operations. I just did the opposite of these two things to get back to my solution. Now, in these examples on the right side of the page here, so this equation says x plus 3 equals 2. I don't want to know what x plus 3 is. I want to know what x is. See, this is telling me that some unknown number with 3 added to it gives me 2. So the way I get x by itself or isolated, you'll hear that term used sometimes, is I do the opposite. See, this has a 3 added to it, so they do the opposite of adding 3. Make sure you do it to both sides, though. The opposite of adding 3 is to subtract 3 from both sides. So I'm going to subtract 3 from both sides, and see on the left here, see this, I'm going to cross those out because essentially that adds to 0. Adding 3 and subtracting 3 is the same as doing nothing, same as like adding 0. So that's why I just have x on the left here, and 2 minus 3 is negative 1. So negative 1 should be my solution. And the way we check that is we put negative 1 in place of x in the equation and see if it gives the same value on both sides. Now the only place to evaluate anything is the x plus 3 on the left. So I'm going to put negative 1 in place of x here. So negative 1 plus 3, and that does give me 2. Give me 2. As long as it gives me the value that's on the other side, then that means that x should be negative 1. That's how you check it. Second one here, c minus 7 is 12. So I want to isolate the c, get the c by itself. So I do the opposite of subtracting 7, which is to add 7 to both sides. So that negative 7 and 7 add to 0, so that's why I just get c on the left here. And 12 plus 7 is 19. So 19 should be my solution, and we can check it by taking the left side expression here and putting the 19 in place of c. 19 minus 7 is 12. See, it equals what's on the other side, so that means that 19 should be my solution. Now, before we get into the next one, let's say I made a mistake here. Okay, maybe I added 12 and 7 incorrectly, and I thought that for some reason, let's say my solution was, let's say 23, for example. Okay, let's say I thought that c was 23. So it's c minus 7 instead of 19 here. I would put 23. So I would think to myself, well, what's 23 minus 70? Oh, yeah, it's 16. Notice that it's not the same as what's on the other side. So that's how the check would tell me that 23 is the wrong answer, because it doesn't give me the same value on both sides of the equation. Okay, so that's why you check and how it tells you if you're right or wrong. Let's get rid of this writing here. Okay, next one, 2n minus 8 equals 2. Now, these are called one-step equations because I did one thing to both sides in each case to get the solution. This is called a two-step equation often because there's two different steps we're going to do to find what the solution is. And when you have two steps, you see you have an n term, something added or subtracted equals some other number. Okay, that's a two-step equation. There's different kinds too, but the basic strategy is this. Get rid of the adding or subtracting from the variable term first, and then well, I'll explain the second step. So you see the 2n has 8 subtracted from it. So I'm going to, the opposite of subtracting 8 is to add 8. So this adds to 0, so I just have 2n on the left, and 2 plus 8 is 10. So 2n equals 10. So that means twice n is the number 10. So I want to know what n is, not what twice n is. And you see the 2 and the n are multiplied. The opposite of multiplying n by 2 is to divide by 2. So these 2's divide out to give you a 1n on the left. And 10 divided by 2 is 5. Now, we don't usually write the 1n. We normally just write it as n equals 5 because 1n and n are the same thing. Now, if you happen to notice this equation is a bit familiar, it's the same one we had actually over here. So let's do the check now. I did say I was going to show you how to do the check here. So the left side expression is 2n minus 8. So I'm going to write 2n minus 8. I'm going to put the 5 in here. So 2 times 5 minus 8. So remember your bed mass. We multiply before we subtract. So that's 10 minus 8 is 2. And as long as it works out to be the same as what's on the other side, then that should be the solution. Now notice I did a little bit of different opposite operations than I did over here. Sometimes there are more than one path to get the solution. Okay, so it doesn't always be that every single person has to do the same exact thing. Okay, sometimes there are other options, but as a general rule, in a two-step equation, get rid of the thing that's subtracted or added to the variable first, and then once you get that, divide this number out or whatever other opposite operation you need to do. So let's take a look at, there's two more examples on the last page here. And each example is getting a little bit more complex. If you want to see some more examples in the description, I'll put a URL to another video I made. I think there's 7 different examples in that. Some have fractions, some don't. So there's a real smorgasbord of different kinds of examples. So you can check that out if you'd like to see some more. Now in D here, 5 bracket 2x minus 3 means that 5 is going to be distributed into the 2x minus 3. So I multiply 5 by 2x to get 10x, and 5 times negative 3 is negative 15. This stays the same, the 4x stays the same, the 1 stays the same. And anything you can ever do to make the equation simpler, do it. So see, I see a couple of like terms here, the negative 15 and subtract 4. Instead of saying subtract 15 and then add 4, negative 15 plus 4 is the same as negative 11. So that is the same as just subtracting 11. Now this equation is a little more complex than the last one because there's numbers on both sides, which that one had, but there's also variables on both sides. And when you have variables and numbers on both sides, basically you want to do opposite operations to get the variables together on one side and the numbers on the other. And it doesn't always have to be the variables on the left, although that's what I'm going to do. It can be the variables on the right and the numbers on the left, but you just one on one side and one on the other. So if I want to get rid of the x's, the 4x from the right here, then the way I get rid of that 4x is I would just subtract 4x from both sides, because 4x minus 4x is 0. You have to think of, what would I do to get rid of that 4x? You see, if, for example, just as a little aside here, let's say it had been a negative 4x there. Okay, then what I would do is I would add 4x to both sides, because negative 4x plus 4x would give me 0 here. Okay, if it had been a negative 4x. Again, you do the opposite. Let's get rid of that writing. So 10x minus 4x is 6x. Minus 11 is just still minus 11. That's nothing, so that's why we just have the 1 on the right here. Now the 6x has 11 subtracted. This is a lot like the example on the bottom of the previous page. So I want to get the 6x alone. So it's subtracted by 11. So I would add 11 to both sides. So that's gone. I just have the 6x here, and 1 and 11 add to 12. So 6 times x is 12. I want to know what x is, though. So see, the 6x again means 6 times x. So I would divide both sides by 6 so to get the x alone. So these 6's will divide out. So x would be 2. Now these checks are more what's called a formal check, okay? Because there's expressions on both sides. See, all the examples in the previous page just had a number on the right side. This has an expression. So what we do, and I'll write them both out here. So this is the left side expression. That's what LS stands for. And this is the expression on the right side of the equation, so RS stands for. Some teachers you'll see actually do this. No, actually I want to do that. I want my pen. Yeah. Okay. Just a second here. Right. Oh, I see what I'm doing wrong here. I'm pressing the wrong keystroke. Some teachers you'll see do this. They won't have the LS and the RS. They'll make a table, and you just fill out the two values. So that's another way you'll see teachers do that sometimes. Let's get rid of that writing. Back to my pen. Okay, so what I'm going to do is I'm going to put the 2 in place of x here. So this would be 2 times 2 in the brackets. So remember BEDMAS, we do what's in the brackets first, and inside the brackets I have multiplying and subtracting, so I do the multiplying first. 2 times 2 is 4, and then subtract 3. So again, I want to simplify what's in the brackets first, so 4 minus 3 would be 1. And then 5 times 1 is 5, plus the 4 is 9. So the left side worked out to be 9. So I'm going to take the 2 and do the same thing over here on the right side. I'm going to put it in place of x. So this is 4 times 2, which of course is 8, plus 1 gives me 9. So as long as those two things work out to be the same, it doesn't matter what they are. They could both work out to be 51 million. That would still be okay. That would mean that x is 2. So what we say is, since the left and right sides are the same, that means that x is equal to 2. So last example up here, I chose one with fractions and one to show you an example with fractions. So we have denominators of 2 and 4 here. And what I want to do is multiply both sides by numbers so that the 2 and the 4 will divide out, so we don't have any fractions anymore. Now, if you can't find that number, multiply the denominators together. Like 2 times 4 is 8. 8 would actually work here. The numbers will be a little bit bigger than what I'm going to do, but it would still work. It would still give you the same solutions. So the smallest number that 2 and 4 both divide into is 4. So I'm going to take both sides, this multiplied by 4 and this multiplied by 4. And I'm going to show you 2 different ways to do this. Okay, so first of all, remember how to get my pen back right here. So first of all, I'm going to divide 2 into this 4. So that's 2. So on the left here, I've actually got 2 times the 3n minus 4. And on the right here, see 4 divides into 4 once. So it's really 1 times negative 5, which is negative 5. And if I expand out, 2 times 3n is 6n, 2 times negative 4 is negative 8, and negative 5 on the right. Okay, so that's one way to get to this. Now, another way, and let me get rid of my writing. Let's go back to my pen here. Another way is to do this. Think of these are both over 1. So 4 times 3n, just multiply it in, would be 12n. And distribute the 4 in here, and multiply by this negative 4 would be negative 16. Over. Now in the denominator I have 1 times 2, which is 2. Equals, and negative 5 times 4 is negative 20. And in the denominator, this 4 times this 1 is 4. So now, see, the reason we multiply by 4 is so that the denominators are divide out, no fractions anymore. So 2, actually let's go back to my pointer. 12n divided by 2 is 6n. Negative 16 divided by 2 is negative 8. So that will simplify to 6n minus 8. And negative 20 divided by 4 is negative 5. So it still gets you to the same place. Okay, so there's 2 different ways to do that. Let's get rid of this writing. So this is a lot like the C example on the bottom of the previous page, or this part right here. So I want to get the 6n alone. So subtract, it has 8 subtracted from it, so I would add 8 to both sides. So that adds to 0. Negative 5 and 8 adds to positive 3, and this would be just 6n on the left. And then, like I divided by 6 here, I would do the same thing here, divide by 6, so that this simplifies to just n. And 3 over 6, if I divide top and bottom by 3, I get a half. Okay, solutions can be fractions. They don't have to always be a whole number or an integer. So I'm going to show you the check for this one. So this is the left side expression. This is the right side, fraction. There's nothing to evaluate here. So I'm going to substitute the half in place of n here. And when I simplify this, I would hope to get negative 5 quarters, because then that would mean that a half is the correct solution. Now notice I changed the 3 into 3 over 1 because I'm multiplying fractions. So 3 times 1 is 3, and in the denominator 1 times 2 is 2. I changed the 4 to 4 over 1 because I'm subtracting fractions here. So I'm subtracting fractions here. So I want to get a common denominator. I have a 2 here, a 1 here. So I'm going to multiply this by 2 top and bottom. So that's why I've got this step here. This will give me my common denominator. So this 3/2 stayed the same. 4 times 2 is 8. 1 times 2 is 2. Okay, so now I can subtract these fractions in the top. 3/2 minus 8/2 is -5/2. So that numerator is -5/2. And I changed this 2 into 2/1 because, you see, this means division. The way you divide fractions is you take the numerator fraction and multiply by the reciprocal of the denominator, which would be 1/2. So in the numerator, -5 times 1 is -5, 2 times 2 is 4 in the bottom, and notice I have the same value as what's on the right side. So again, since the left side and right sides are the same, then n does equal 1/2. And again, if you want to see a few more examples, check out my other video. The URL is in the description for this one. And that's the end of the tutorial.